Okay, yesterday I told you that our unit that we're starting today, it's called rational functions. And what we know about the word rational is that it can be written as a fraction. So this lesson today is a pretty easy introduction into it. The one I've got starred there, like I said, by Garrett, you see the title is Inverse Variation today, so that's the one we're going to be using the most. And we're talking about rational functions. Well, that's written as a fraction, so that's what we're going to see through this. Now we're going to get into some more difficult rational functions that are pretty big and involved, but today it's going to be pretty easy, basic stuff. So get those two variation formulas copied down so we can use them. Key for you as you're writing those that you can see, if it's a direct variation, it's some number times x. If it's an inverse variation, it's some number divided by x.
Coach!
Yes.
Can you pick up for a second?
Sure.
I'm sorry. Don't be bad.
What? I think it's just PM. Yes. I think. Yes. And that Stuart and Lola too. That's the way I understand it now. Thanks, bye. I got that page ready to roll. Let's move.
Maybe.
Alright, it says down there, I think this is what I was fixing to say. It says down there at the bottom that A is the constant of variation, and that's the way I was reading that to you a minute ago, Marshall. A will be some number. Remember, constant is a number. Okay, so there'll be some number being multiplied by x to be direct, some number being divided by x to be inverse. Now, notice in both of these that the equation is solved for y. So it may not initially be ready. You may have to do some work to solve it for y in the beginning. Okay? Alright, so here we go. Chloe said yes. I've got xy equals 5. I'm going to write you 3 problems here. Then I got y equals x minus 4. And then I got y divided by 2. So y is equal to x. Okay, here's what our directions say. Tell whether they show a direct variation, an inverse variation, or neither. So on numbers 1, 2, and 3, we got to figure out if it's a direct variation, an inverse variation, or neither. So I just told you something about what we need to do for number 1. Look at the 2 formulas you wrote down. What variable was solved for on those? The y, right? So number 1, I need to get that y all by itself.
Yes.
What would I do to get the y all by itself?
Divide by x.
Okay, so we divide both sides by x. That leaves me with y equals 5 divided by x. Now, if I were to say that to you the way I read the first page to you, this would say y is equal to this number divided by x. Does that meet one of those? Yes, it does. Grant's correct. This one would be an inverse variation. Because we got some number being divided by x.
The second one,
Okay, on number 2, the y is already by itself, so it's already solved for y. So we're looking here, our choices are if x is being multiplied by a letter, by a number, no, it's not. Is x being divided by? No. So Grant will be correct, that one would just be neither. Okay, what do I need to do on the last one to get the y by itself?
multiply.
Well, it's being divided by 2, so we're going to multiply by 2. So that'll give us y equals 2x. So now I would say I got y is equal to some number times x. So it would be a direct. Very good. Easy schmeezy. So key in that, solve for y. Then after you solve for y, if you got multiplication, it's direct. If you got division, it's inverse. If you got neither, it's neither. Okie dokie, artichoke. Alright, let's look at to tables now here. There's number one. Now I'm going to go and get number two written while you're writing. Alright, so I got number 1 and 2 there for you, 2 different tables. The directions say, tell whether X and Y show a direct variation, an inverse variation, or neither. So it's the same directions again. Direct variation, inverse variation, or neither. Okay. Anybody got any guesses on how we could start rolling here? We could. That's not a bad idea. And if we ended up getting something like that, that could lead us somewhere. But I want to start this a little bit different. And what Grant was talking about, and it's not a bad idea. Remember when we said, okay, from -12 to -6, what happens? From -6 to -4, we found that first level.
Yeah.
That's not a bad idea at all. But here's what I'm concerned with. Right? In this, if it's direct, we got, so we're not concerned with addition and, I said that wrong, dumb butt. What's that? Multiplication and division? Isn't that what we're concerned with here?
Yes, it is.
Okay, so what would we get if we went through these? On my first pair, what's X times Y?
-24.
Okay. On my second pair, what's 4 times -6?
-24. Oh, they're all negative
6 times
-24.
-4.
-24.
Okay, 8 times -3. Okay, so when we multiply, we got the same thing every time. Now let's look at our Y divided by X. -12 divided by 2. -6. -6 divided by 4. It's not going to be the same every time, is it? -4 divided by 6. And -3 divided by 8. Okay? So we had a constant up there when we multiplied, but we did not have a constant when we divided. Okay, now hold on. This is where it gets tricky. Laney Joe's on to it. So this means that X times Y equals the same thing every time. So this means that my A there would be -24. But this isn't solved for Y. What would you do to solve this for Y? Divide both sides by X. So Y would equal -24 divided by X, which Laney Joe makes it be an inverse. Good job. Now, did I have to do that row of division there? Once I got this, couldn't I have just went ahead and said, well, it's all constant in that line? Because you're not going to have something that's both, right? I didn't give you that choice. I said direct, inverse, or neither. I didn't say direct, inverse, or both, right? So once I got here, I would have been okay to stop, but I just wanted to show you the process. So we're going to have to repeat the same process over here with these now. Okay? So I'm going to make me a column for X times Y. I'm going to make me a column for Y divided by X. Alright, so X times Y. 1 times 2 is 2. 4 times 2 is 8. I'm going to stop there. Because I already know it's not the same every time, right? So let's go here. 2 divided by 1 is 2. 4 divided by 2 is 2. 8 divided by 3. It's not 2, is it? So I don't have a constant on either row. So would this be direct, inverse, or neither?
Neither.
Very good. Y'all are smartical.
Is that an 8/3?
Yes. Green giant. All right. This next type of problem. This one I'm going to tell you that we've got inverse. So this next type of problem, you'll always be told what type of variation. We don't have to figure it out. This problem reads, the variables x and y vary inversely. So first thing I'm going to do, Chloe, when I hear that, is I'm going to write the model for inverse. So the reason I wrote that is because the problem read, the variables x and y vary inversely. And I know inversely is some number divided by x, right? Okay. So it says y equals 4 when x equals 3. Then it asks us to find y when x equals 2. Okay, so here's how this is going to roll. This is completed. We've got an x and we've got a y. So we can plug an x and a y in here to figure out an a. Then we can take that a to the partial to figure out the y. Okay, so we got to know a to figure out y. We can use this to figure out a. Okay, so we're going to start off with the completed information right here. Y is 4, so 4 equals, hey Paul, a we don't know yet, divided by x, and x is 3. Okay, now you can either read this like a little baby equation or you can solve it algebraically. 4 is the same as, here's your baby equation, 4 is the same as what divided by 3? Okay, and it is 12, and if you don't think that way, a is being divided by 3, undo that with multiplication of 3. 4 times 3 is 12, so you get your 12 either way. So now we know our a, we're going to bring him over here to this party to help figure out our y. So y equals a divided by my x, which is 2. Right? Pretty simple. Okay, I did not do any difficult math there. You did not do any difficult math there. So thought process, use all of it to get a, and then take that to the partial to get your missing. Okay, let's try one of them on your own. Good idea, Chloe. Thanks.
Good idea.
I'm going to tell you that, bless you, x and y vary inversely. So start by writing that. Y is 8 when x is 4. Find y when x is negative 16. Okay, see if you can figure out what y is when x is negative 16. Just like the problem we just did. Go. Yes. I'm going to rewind for a second. My bad, Rob. Got it? No problem. Just want to make sure. Alright, here's the one you were working on. Finish that up if you don't already have it.
Is that negative 16?
Yes, negative 16. A of 32, you can't get the right answer. Everybody see how we got 32? Does anybody need me to set that up? Are we good? Yes or no? Everybody good?
Yeah.
Okay. So now I'm going to take the 32 and I'm going to take the negative 16. And don't think that you're going to have to figure out y over time. I could have switched these on you. You could figure out x as well. As long as you've got one of these and you're constant, you can figure out the other. But I asked you for y again, so I'm going to say y equals 32 divided by negative 16, and that's an easy negative 2. Everybody good? I like it. I like it a lot. Easy schmeezy. Easy schmeezy. Alright, let's do this fun problem now.
Is it really fun though?
Oh,
No.
it's loads, Michaela. Loads. The time t in hours it takes a group of workers to build a cabin varies inversely as the number n of workers. So my time t, check this out, varies inversely as the number of workers. Holy cow, you just wrote an inverse variation. Say it again,
Is
sister.
it like this thing?
Exact same thing, we just got different variables now. Okay? It takes 12 workers, so that's an N, isn't it? Number of workers. It takes 12 workers, 15 hours, so that's T, to build the cabin. So part A, make a table. It's like my X and Y, right? Put those like you would an X and a Y. Make a table showing the time it would take to build the cabin if the number of workers is 6, 20, 24, or 30. Okay, so you can do this several different ways. You could use some common sense and figure it out, but I want us to figure it out based on our A. So can I use that 12 and 15 to find my A real quick?
Yes.
Of course I can. So I know, let me get a new color here. I know that 15, that's my T, is equal to A divided by 12. So I multiply 15 times 12 gives me a constant of 180. Grant typed me up on that. Okay, so all I'm going to do to get my time on these now is do 180 divided by whatever my number of workers is. So what's 180 divided by 6? 30. So if I had 6 workers, it would take me 30 hours. Now, push pause and see if that makes sense. When I had double that amount of workers, it took me half the time. So it makes pretty good sense. So now just keep going. 180 divided by 20. 180 divided by 24. She said 9 was next. What's 180 divided by 24? 7.5 hours. And then 180 divided by 30? 6 hours. Okay? So that was part A, make a table. Now the part B is the common sense question. What happens to the time it takes to build the cabin as the number of workers increase? More workers you got, less time it's going to take. Pretty tough to figure that one out, right? That's true in any situation. Pretty good, pretty good. I like that one, Michaela. That was fun, wasn't it?
It wasn't as bad as I thought. But it wasn't fun.
Yeah.
Sorry to burst your finger.
9 burgers to go past.
Man.
Yeah, I thought she was going to kill us.
That'd be nice.
Yeah. Imagine the money they could make. Hour and a half to build a cabin. How many cabins could you build in a day?
Too many.
You can build 12 a
But
day.
then you'd also have a lot more people to pay too.
Yeah. But then you'd still make some good.
Yeah. Yeah, it probably would average out about the same. Alright.
Yeah.
Does it take longer to build a cabin house or just a brick house?
It's actually about the same. I went through, I built a log cabin. I didn't build it, but I had it built. And everything times out about the same.
Oh. Why would you want a log cabin just for looks?
Yeah, I mean, it's what I've always wanted.
Does it ever, like, the wood ever rot?
It won't before I'm dead.
Oh. So it takes a while.
Yeah. I mean, its longevity is about the same as a normal house.
Does it cost more?
A little bit.
Yeah.
The logs cost more than the 2x4s do.
Oh, okay.
Negative 56.
Was that? No.
What's the matter?
Never mind.
Okay, mine could be.
Are these two different problems?
These are 3 different problems. Alright, so 3 different problems I got for you here. Up on the top 2, I kind of wrote them in a whopper-jawed order. Number 1 and 2 up here, up on the top 2, I just want you to tell me if those are a direct variation, an inverse variation, or neither. Okay? So these 2, you can put a D, an I, or an N. Direct, inverse, or neither. On this one, this whole big wad down here is number 3. It varies inversely. When Y is 6, X is 6. So tell me what Y, I put 2 Y's there. You can't do that. Tell me what Y is when X is negative 4. Let me change that second one to an X. There we go. Tell me what Y is when X is negative 4. So see if you can get those 3 down in your notes real quick. If we do good, it'll be a wrap.
Is that a 17?
It's 12?
Yes, yes. 4, 7, 9, 12. Thank y'all. 4, 7, 9, 12.
Direct, inverse, or neither.
Mm-hmm.
Is that put together?
On the bottom, yes.
I don't know how we do it without them. Other people.
Well, and the problem they wouldn't, when I copied this out of the book, they didn't give me this, but what they did give me was, they told me it varied inversely. So because I read that, I wrote that.
Oh. Everybody back got them? Need another second? Okay, before I can decide on number 1, if that's direct, inverse, or neither, what do I need to do? Fill divide by itself.
Okay, good. I gotta get the y by itself, which means divide by x.
Oh.
So y would equal negative 56 divided by x. Now you ought to be able to say this says y equals some number divided by x. So which of the three is that? Direct, inverse, or neither? Inverse. Very good. Okay. Now when we had a table, we looked for either that relationship or that relationship. So if I start here on my x times y, 20 times 4 is 80. What about 35 times 7? Okay, I know 5 times 7 is 35, so it can't be 80. So that would be good there, Chloe. It's 200 and whatever she said. So let me go divide it now. 20 divided by 4, that's 5. 35 divided by 7, that's 5. 45 divided by 9, that's 5. And 60 divided by 12, that's 5. So what we can say here, let me get a new color because I'm going to be all jumbled up. Y divided by x equals a constant of 5. But I need to solve this for y. My y is being divided by x, so multiply by x. So y would equal 5 times x. So I got y equals some number times x, which means this table is direct. Good job. That was some fun stuff there, Michaela. So, the shortcut for you, when it's a table, even though multiply means direct, when it's in table form, it's switched, isn't it? If you get the multiplying a same number, it's going to be inverse. If you get the division a same number, it's going to be direct. So, that confuses you, then just write it out like I did. But some of y'all can skip that step. All right, on the last one, we need to figure out an A first. What did you get for an A? Okay, everybody agree that our constant would have to be 36. Okay, so we're going to say down here on my second line that y equals 36 divided by negative 4. So you're right, Miss Bella, you get negative 9. Hot dog, hot diggity dog. Alright, so tomorrow's stuff, we're going to start looking at the graphs of some rational functions. And listen to me real quick, because I'm going to ask you this tomorrow. Listening, shh. If we got a rational function, that means a fraction. What type of number can you never have on the bottom of a fraction? No, you can have a negative. 0. Good, River, you can't divide by 0, can you? Try it in your calculator. 7 divided by 0 gives you an error. So that means when we start graphing these that our denominator, our bottom, is going to be very limited. Which means you're going to have the big word that starts with an A that you approach but never touch. No. Big word that starts with an A that you approach but never touch. Close. Asymptotes. Very good. Remember those from last unit? Asymptotes. We approach it but never touch it. So that's going to come in big when we start graphing tomorrow. Okey-doke. Fabulous job on easy schmeezy stuff today.